This is a video about functions, and particularly about identifying functions. There are three different ways in which you may be presented with information and asked to identify whether it represents a function or not. You may be given a graph, you may be given a mapping diagram, or you may be given a set of couples. Let's start with a graph. The way that we'll decide whether a graph represents a function or not is to use the vertical line test. So here's an example. In this diagram, I have a graph. If this graph represents a function, then if I draw a vertical line, it should only ever intersect the graph at most once. Here I've drawn a vertical line. It only meets the curve of the graph in one place. Here's a second vertical line. It also only meets this curve or this graph in one place. No matter where I draw a vertical line in this diagram, it will only intersect with this curve one time. There is nowhere that I can draw a vertical line that will go through this curve twice. So this graph passes the vertical line test, and this diagram represents a function. Here's a second example. Again, to decide if this graph represents a function or not, I'll draw some vertical lines and see how often they meet the curve. I've drawn a vertical line here on the left. This vertical line doesn't meet the curve at all. This isn't a problem. This does not stop the curve or the graph from being a function. Here I've drawn another vertical line. This vertical line meets the curve in two places. Now that's a problem. Once a vertical line can cross through the graph in two different places, that straight away tells me that this is not a function. Here are two more diagrams. Pause the video for a moment until you decide whether or not each of these diagrams represents a function, and then play and check if you are correct. For the first diagram, no matter where I draw a vertical line, the line will only cross the graph in one place. At no stage can I draw a vertical line that will go through the graph twice. So this graph represents a function. In my second diagram, it's quite clear that a vertical line can pass through the curve or the graph multiple times. This means it is not a function. So the rule is that if a vertical line cuts the graph more than one time, then the graph is not a function. Next, we'll look at mapping diagrams. A mapping diagram is made up of two separate sets, one that holds the inputs and one that holds the outputs. It usually looks like this. We have values for inputs that are linked to specific values for outputs. The rule for identifying if a mapping diagram represents a function or not is very straightforward. For mapping diagrams, the rule is that each input should have exactly one arrow coming from it. So the mapping diagram that we see here, since each input has one arrow coming from it, is a function. Here's a second example. Take a moment to have a look at this mapping diagram and decide, do you think it's a function or not? So we look at the inputs and we see that each dot here, each value, only has one arrow coming out of it. So that means yes, we have a function. Let's look at one more example. So look at this diagram for a moment and decide whether you think it's a function or not. Okay, so the rule states that if it's a function, each input should only have one arrow coming from it. But you can actually see this time that the input 1 has more than one arrow coming from it. That means that this diagram does not represent a function. The last way in which information may be presented to us for a question of this type is as a set of couples. In a set of couples, the first number in each bracket represents the input and the second number represents the output. The rule is very simple for sets of couples. Each input must only appear once. So I'm only really concerned with the first number in each bracket, the first number in each couple. Once there's no repeat amongst these, then I have a function. So this list of couples represents a function. Have a look at this second example. Do you think it represents a function or not? Again, remember, I only have to look at the inputs. 1, 2, 3. There's no repeats. So this example is a function. What do you think about this example? Is it a function or not? If I focus on the inputs, 1, 1, 2. The input 1 repeats itself. That means this is not a function. If you're asked to give a reason in this case, you would simply say this is not a function because there is a repeating input.